In this problem, we're asked to build a function whose graph is provided there in the picture. So this problem, it's a little backwards from what you're used to. You're used to being given a function and then you're asked to graph it. In this problem, we're given the graph and asked to write the function. But we can think about it in a similar way, which is to first think about what the parent function would be in this case. Since this graph is a parabola, we would expect the parent function to be y equals x squared. This is the graph that has that basic shape that we see in the picture. So that's our starting point. Then we think about the fact that, okay, so plain old y equals x squared has a vertex right at the origin at 0, 0. And the vertex in this graph is down here with coordinates 1, -3. So it appears that that vertex that was initially at 0, 0, right here, my graph was like this. I'm actually, as I graph this, let me go ahead and point out, I'm thinking of a few other points that are on the graph of y equals x squared, like 1, 1, because 1 squared is 1, and 2, 4, because 2 squared is 4. And then over here, -1, 1, because -1 squared is +1, and -2, 4. So I'm thinking of a few other exact points when I draw this graph. Okay, but focusing right now on the vertex here, it appears to have been shifted right 1 and down 1, 2, 3 units. So the graph was shifted right 1 unit and down 3 units. So we have to think about how those transformations occur in the equation of the function. Any horizontal shift is a result of adding or subtracting a number inside of the function. So let me set up a parentheses. That shift right 1 is going to occur by adding or subtracting a number inside of the squaring function. Remember that the horizontal shifts do the opposite sort of the way that the function reads. So right 1, you think of it as forward 1, but in the equation it appears as x minus 1 squared. So this would be the parabola shifted right 1 unit. Now we also need it to be shifted down 3 units. Remember that vertical shifts occur when you add or subtract a number outside of the function. And the value that we write is directly related in this case to the shift. So down 3, we want to go -3. Those vertical shifts are more intuitive in the equation. All right, so we have an equation here. We might just double check that this will work, that this will generate some other points on the graph. This is just to ensure, well, let me say this. There's no reflection in this graph. The parabola is still opening upward. We need to just consider if the graph has been stretched or compressed in any way. Now I'll go ahead and tell you, in my mind, I'm already thinking that it is not stretched or compressed because plain old y equals x squared, get my highlighter, from the vertex goes up 1 and over 1 in both directions, and then over 2 and up 4. And notice that this graph is still, it's got that same rate of change here, over 1, up 1, over 2, up 1, 2, 3, 4, over 2, up 1, 2, 3, 4. So I don't see a stretch or compression here. But another way for you to double check would be to substitute some values. So let me take this point, for example. This is saying that when x is 0, y is -2. Well, let's see if that works in the equation that we've written here so far. Is -2 equal to 0 minus 1 squared minus 3? Well, this -1 squared is +1 minus 3. That is equal to -2. So this looks good. We could also use this point here at 2, -2. If x is 2, does y equal negative 2? Let's see. So that would be 2 minus 1 squared minus 3. That's 1 minus 3. That is indeed negative 2. So this is the equation of the graph provided.